Welcome to the third video in a series of 4 about the unit circle. In this video, we'll be given information about one trigonometric value, and we're going to use that information to deduce others. Before we start the actual problems that are typical of this variety, I need to point out that there are more than 16 points on the unit circle. Of course, if you've watched the last 2 videos, we've spent a tremendous amount of time focusing on these 16 points, the multiples of pi over 6, you may see them in red, the multiples of pi over 4 in green, and the multiples of pi over 2 you may see in black. And while these points are pretty critical to our understanding of trigonometric functions, they're not the only 16 points on the unit circle. Here's an example. Here's a point I chose on the unit circle. I happen to know of this point from other studies. There's no reason that the typical student would think of this point, but this point happens to be the point 3/5, 4/5. What does that mean? Well, it means it has an x-coordinate of 3/5, which is about 0.6, and a y-coordinate of 4/5, which is 0.8. Okay, just an example to remind us that there are more than 16 points on the unit circle. Furthermore, I know this point is on the unit circle, not just because I plotted it, but because you may recall from the first video, if you watched it, that x squared plus y squared equals 1 is the equation of all points x, y on the unit circle. And I know that 3/5, 4/5 is such a point because when I plug it in and do the algebra, I do in fact get a true statement. I think we could all agree that 25/25 equals 1. And so that's, again, just an example. Now, why do I bring this up before we start? Because we're going to be dealing with points on the unit circle that are not necessarily, could be, but aren't necessarily our favorite 16. Please keep that in mind as we watch these examples. So now let's look at a problem where we're given one trigonometric value and a little extra information, and we're asked to find another value. These problems are always structured in a similar fashion in that they have some given information and a question. Suppose this were the given information and this were the question. One of the key elements to getting from the given information to the question is to transition through some information that you can deduce about this particular a, whatever it is. And what is a? Well, a is the argument of a trigonometric function, and therefore we can think of a as some arc that terminates at some point. I don't necessarily know that this is the exact arc that represents a. I just drew a random arc to generically show that a is some arc and it terminates somewhere. Now, I don't necessarily know what quadrant it terminates in. My picture that I randomly drew had it terminating in quadrant 3, but that's not necessarily the case. And so to get an accurate picture of a, this arc, I'd be well advised to try to determine first what quadrant a terminates in. In other words, in what quadrant is the terminal point of a? Okay, so here goes the deductive reasoning. It's tricky, and you may have to hit pause at a few moments just to keep your brain caught up. We know that the sine of a is some positive number. They told us it was positive 3/5, so we know that the sine of a is positive. The sine of a is the same as the y-coordinate of the terminal point. And therefore, the y-coordinate of the terminal point must be a positive number, 3/5 specifically. Therefore, a, this arc, must terminate in quadrant 1 or 2. I don't know which yet. Don't we agree that quadrants 1 and 2 are the places that have positive y coordinates. That's not new information. I'm going to move on. If you need to hit pause and analyze that chain of logic, please do. You don't want to get lost as I continue. So hopefully you've convinced yourself that A must terminate in quadrant 1 or 2 just based on the fact that the sign that was given, 3/5, is a positive 3/5. But knowing that it terminates in quadrant 1 or 2 isn't enough information necessarily to finish the question. And so I'd like to narrow it down. Is it quadrant 1 or is it quadrant 2? Let's go through another chain of deductive reasoning. Back to the issue of what quadrant does the terminal point of A lie in? Look right here. They tell us that the cosine of A is less than 0. What numbers are less than 0? Negative numbers are less than 0. And therefore the cosine of A must be a negative number. Now remember, A is some arc, but by definition, the cosine of A is the x-coordinate of that terminal point. So if the cosine is negative, and the cosine is the x-coordinate, then the x-coordinate must be negative. If the x-coordinate is negative, in general, couldn't we say that A would have to terminate in quadrant 2 or 3? After all, quadrant 2 or 3 are the locations where the x-coordinate is negative. Again, you may want to hit pause if you got lost in the logic. It's okay. Take your time. Hit pause if you need to and convince yourself that this chain of logic is sound. And so now we've deduced that A must terminate in quadrant 2 or 3. But we had already prior to that deduced that A must terminate in quadrant 1 or 2. Look at the two statements under the deduced information. You may see them in purple. Isn't the logical conclusion then that A must terminate in quadrant 2? And that's my first big deduction. I know that A terminates in quadrant 2. So let's try to get an estimate of where this terminal point is. We know that the sign is positive 3/5. And that means that the y-coordinate of this point must be 3/5. So on the one hand, I know the y-coordinate of the point is 3/5. I know it's on the unit circle, but I also know that it's in quadrant 2. The only point in quadrant 2 that has a y-coordinate of 3/5 is this one. And so now I know approximately where arc A terminates. What I don't know about it is the x-coordinate. So I'll generically call that x for the moment. That would really benefit me if I could find x, because after all, the question being asked here is to find the tangent of A. It would be really helpful to know the x-coordinate of that point to ultimately finish this question. So let's make it our business to go about finding the x-coordinate of this point. Well, the good news is the point is on the unit circle. Therefore, it must satisfy the equation x squared plus y squared equals 1 at any point, specifically at the point in question. And so I can plug the y-coordinate of 3/5 in, because I know that point has a y-coordinate of 3/5, and now I can use rather ordinary algebra to solve for x. I don't want to turn this into an algebra lesson, so if you need to hit pause and check the algebra yourself, you may be well served to do that. But now I know that x equals plus or minus 4/5. But wait a minute, x is a negative number. You can see that in our picture from the fact that our terminal point is in quadrant 2. So x being plus or minus 4/5 leads me to the conclusion that it must be minus 4/5 because of its location in quadrant 2. So now I've deduced that the x-coordinate of this terminal point is -4/5. Notice how I use the given information through a logical chain of reasoning to make the deductions in the middle, as you may see in purple. I think we've deduced enough information now to answer the question. The question is to find the tangent of A. Well, remember that the tangent is defined to be the sine divided by the cosine. That's equivalent to saying that it's the y-coordinate divided by the x-coordinate of the terminal point of A. But I just spent a lot of time figuring out what the x-coordinate of that point is. And I knew that the y-coordinate was 3/5. Plugging all the deduced and given information into this formula allows me to work that out on scratch paper. That ultimately led me to a final answer of -3/4. Now I'm done with the problem, but a few comments before we move on. First of all, if you want to see the algebra of how I got -3/4, here it is. Furthermore, I'm going to put back the original information just so you can see the bulk of the problem all in one place. You may want to hit pause here and just look the whole thing over. And I'm done, but I want to mention one thing here. If they had asked us for any of the other 5 trig functions other than the sine which they gave us, couldn't we now compute that as well? If I wanted to know the cosecant, or the secant, or the cotangent, I have enough information here to compute any of those. So the theme of these problems is, if you're given one trigonometric value and a little bit of extra information, in this case the cosine of A less than 0, you can not only answer the specific question, but you could answer any of the 5 remaining trigonometric functions just from that given information. And that is the theme of these problems. Let's look at another example. Suppose we're given the cosine of some arc length A and the fact that the tangent of that same arc length is greater than 0. Suppose we're being asked to find the cosecant of that arc length. Again, we're going to have to go through our deduced information to get from the given to the question. But again, let's pose the question of what is A? Well, A is some arc length that terminates somewhere. I don't know where. It's not necessarily going to be in quadrant 2, but just reminding you what A represents. It would be really helpful for us to know which quadrant A terminated in so that we could ultimately answer this question. So we'll go about some deductive reasoning again that will lead us to that conclusion. So in what quadrant is the terminal point of A? See if you can follow this logic. They told us that the cosine of A is -5/6. Ignore the 5/6 for the moment and just think about A being negative, or the cosine of A. So the cosine of A is a negative number. But remember, the cosine represents the x-coordinate. And therefore, the x-coordinate is negative. Now, if the x-coordinate of a point is negative, and I'm not talking about trigonometry here, just making a general statement about graphing. If the x-coordinate of some point is negative, we know that that point must be in quadrant 2 or 3. Quadrant 2 or 3 are where the negative x-coordinates are. That's not new information. Therefore, A must terminate in quadrant 2 or 3. Again, hit pause if you need to review this logic yourself. So now we've deduced that A must terminate in either quadrant 2 or 3. We can use this information here, the fact that the tangent of A is greater than 0, to eliminate one of those two possibilities. So we're given that the tangent of A is greater than 0. Well, what numbers are greater than 0? Positive numbers are greater than 0. and therefore the tangent of A must be a positive number. Now recall that the tangent is the ratio of y-coordinate divided by x-coordinate. But we also know that the tangent is positive. The only way that a division problem or ratio can be positive is if the numerator and denominator are either both positive or both negative. But we already know that the denominator is negative, and therefore the numerator must also be negative. And here's a general statement about graphing. Again, nothing to do with this problem specifically. If you have some point somewhere, and you know the y-coordinate is negative, there are only two quadrants where that can happen. The y-coordinate is negative in quadrants 3 or 4. You really might want to hit pause and study this logic again. Hopefully it makes sense to you that A must terminate in quadrant 3 or 4 just based on that information. But I had already deduced before that it must terminate in quadrant 2 or 3. And if you look at the deduced information in the center of the screen, you may see it in purple. You'll notice for those two statements to both be true, the only logical conclusion is that A must terminate in quadrant 3. Now notice I haven't used the 5/6 itself yet. I've simply used the positive and negative nature of tangent and cosine in this particular case to deduce that A terminates in quadrant 3. That's extremely helpful for me to be able to draw a diagram. Now let's specifically take the number 5/6. Cosine of A is negative 5/6. That means A must terminate at some point whose x-coordinate is negative 5/6. But I also know that A terminates in quadrant 3. There's only one point in quadrant 3 that has an x-coordinate of negative 5/6, and here it is. So now I have a pretty good picture about what the terminal point of A looks like. Now, I know, therefore, that this point must be negative 5/6 comma something. What I don't know is its y-coordinate. But remember, we're being asked to find the cosecant of A. You need the y-coordinate to find the cosecant. Therefore, it'd be really helpful for me to find that y-coordinate. Luckily, this point is on the unit circle, and as such, it must obey this equation. So I can plug in the x-coordinate of negative 5/6, and again do some relatively simple algebra to solve for y. I realize fractions aren't people's favorite thing necessarily. Hit pause if you need to do some of the work on scratch paper or verify that. But what I've concluded here is that y is either plus or minus radical 11 over 6. And I furthermore know that y has to be a negative number. We can see that from our diagram. And so that leads me to the conclusion that y is negative radical 11 over 6. So all this algebra fills in my deduced information column. I now know that the y-coordinate of the terminal point is negative radical 11 over 6. So on to the question of finding the cosecant of A. The cosecant is 1 divided by the sine by its very definition, which is the same as 1 divided by the y-coordinate of our point. But we just figured the y-coordinate of our point. So all you have to do now is work this out on scratch paper, which I did, and simplify it to this. Now I didn't show the work there. If you'd like to hit pause and examine my scratch paper, there it is. I'm going to now put back the bulk of the work so that you can look at this problem in its entirety. And that's the end of this problem. Again, I'd like to remind you that even though we were only asked to find the cosecant, which we did. We could have found any of the 6 trigonometric functions just based on that given information. Let's look at one more example. All right, so in this last example, we're given some information about the tangent, and we're asked to find the secant. And as usual, we're going to have to deduce some information to get from the given information to the ultimate goal of answering the question. So just to remind you what A itself is, A is some arc that terminates somewhere, not necessarily here, I'm just drawing a generic picture, but wherever A terminates, it has a tangent of 2 and a positive secant. That's what we're given on the left side of this problem. But we don't necessarily even know that it terminates in quadrant 2. That was just, like I said, the generic drawing to remind us what A actually represents. But it would be nice to know what quadrant A does terminate in, so let's go through a deductive reasoning chain of logic and see what we can find. So we're given the fact that the tangent is 2. 2 is a positive number. In other words, we're given the fact that the tangent is positive. Well, let's not focus on the 2 right now as much as we're going to focus on the fact that it's a positive number. Now the tangent is the ratio of the y-coordinate to the x-coordinate. So how can a ratio be positive? Well, as we mentioned earlier, there's only 2 ways a ratio can be positive. If the top and bottom are both positive, or if they're both negative. And so therefore, the x and y coordinates of our terminal point are either both positive or they're both negative. And now, just thinking about graphing, not this problem specifically, but just the quadrants and the plus and minus signs of the points, where is it in the graph that the x and y coordinates are both positive? And where is it that they're both negative? Well, they're both positive in quadrant 1. They're both negative in quadrant 3. And so far, just from the fact that the tangent equals 2, I can deduce that A must terminate either in quadrant 1 or quadrant 3. If you need to hit pause, now might be a good time to review this logic before we go any further. And so, hopefully, you've convinced yourself that based on the fact that the tangent of A is 2, that A must terminate in quadrant 1 or 3. But it would be nice to know which one of those was actually the case. And to narrow it down, let's continue our discussion on which quadrant the terminal point of A is in by looking at the fact that the secant is greater than 0. And again, if a number is greater than 0, it's a positive number. So we can deduce that the secant of A is a positive number. But let's not forget that the secant is the ratio 1 divided by the cosine, or 1 over the x-coordinate. So if the secant is positive, then 1 over the x-coordinate must be positive. Well, how can 1 divided by a number be positive? Well, only when that number itself is positive. Therefore, we can deduce that the x-coordinate of the terminal point must be positive. And thinking about graphing in general, again, not this problem, but just asking ourselves, where on the graph is the x-coordinate positive? One comes to the conclusion that it must be in quadrant 1 or 4, and therefore that's where A must terminate. And so now, I've deduced 2 facts about the terminal point of A. But looking up at the deduced information in the middle, you may see it as purple, it's pretty clear that A must terminate in quadrant 1, because both of those statements must be true. So all of the plus or minus signs in consideration have led us to the conclusion that A terminates in quadrant 1. Now let's consider this particular point right here was somewhat randomly chosen. We really don't know where in quadrant 1 A terminates. I mean, the tangent is 2, right? But that doesn't necessarily give us the x or y coordinates. Recall that the tangent is neither the x nor y coordinates, it's the ratio of the coordinates. So we don't really know the x coordinate of this point, nor do we know the y coordinate of this point. And so therefore we will just generically call it xy. Now because we're trying to find the secant, and that's our ultimate goal, it would be nice to know the values of x and y so we could compute that. At the very minimum, we need to know what x is. But we don't know x or y at this point. So here's what we're going to do to help us find those values. First of all, we know that this point is on the unit circle, and therefore it must adhere to the equation x squared plus y squared equals 1. Fair enough. But without knowing x and without knowing y, is there anything we can do with this equation? Well, not in isolation, but we know more than just that this point is on the unit circle. We also know that the ratio of y to x is 2. Well, how do we know that? Well, remember, the tangent is 2, but the tangent is the y coordinate divided by the x coordinate. So I can replace tangent with 2 and make another equation. Now, neither of these equations on their own could be solved for x or y numerically, but when put together as a system of equations, we should be able to solve for x and y. So what I decided to do was take the top equation, cross multiply by x, therefore solving for y, and substituting y equals 2x into the equation for the unit circle. And what I've done here is create an equation that I can solve for x. And if I can solve for x, I can solve for y. Not that I'll need to in this particular case, because we're trying to find the secant. More on that in a minute. Watch the algebra here as it unfolds. And what I've done here is I've solved this equation for x, and I got plus or minus 1 over radical 5. Well, which is it? Is it plus or minus? Well, we've already deduced that the terminal point of A is in quadrant 1. Therefore, x is positive. So I now know the value of x, and I now know, looking up at my deduced information, that the x coordinate of the terminal point is positive 1 over radical 5. Now, before we proceed, two things of note. First of all, we generally don't want to leave a radical in the denominator. It's considered bad form in some sense. But also of note is that we could now solve for y if we wanted to. And under certain circumstances, I would plug this value of x back in and solve for y into any of the equations you see. But in this particular case, there's no reason to worry about either of those concerns, because we're only looking for the secant. And being that the secant is 1 over the cosine, or 1 over the x coordinate, I really don't need the y coordinate to find the secant. So substituting in the x coordinate that we just found, and doing some very simple fraction arithmetic, leads me ultimately to the answer that the secant of A is radical 5. So that completes the 3 examples that we have, but there's one thing worth mentioning before we go. In the 3 problems you saw given information and a result about a different trig function. Given information, result. Likewise here. And one thing worth noting here is that in no situation, in none of these problems, did we ever find the value of A itself. Remember, A is the arc length. And it turns out, in each of these cases, that A is an arc that does not terminate at one of the main points on the unit circle. In fact, it's very difficult to actually find the value of A. All we really know is where A terminates. A could be a positive arc, a negative arc, or a very big positive arc that wraps around the circle multiple times. We don't know, and it isn't the point of these problems to do that. So keep in mind when you're doing problems like this, you're given information about A, and you're deducing a result about A only based on where A terminates, without ever having the knowledge of what the value of A is itself. And that completes the third video in this series of 4.